Welcome back. So let's take a look at the next question. And I left this first question that we talked about earlier up on the screen because the next question kind of relates to it. So we're again looking at the most missed questions from our quizzes this past week as we prepare for our final exam next week. All right, so this was a question off of Friday, December 4th's Learning Check or weekly assessment. And again, we are looking at parallel lines. So kind of doing the same thing we had done on our previous problem, I'm going to go ahead and let's highlight those angles that we know are congruent. So we'll go ahead and stick with the same colors that we had used earlier, where all those that are congruent to angle 1 will be green. So that again would be angle 1, angle 4, angle 5, angle 8, angle 9, and angle 12. And again, we can go through and talk about why those angles are all showing up as congruent. Of course, angle 1 and angle 4 are vertical. 4 and 5 are alternate interior, but also angle 1 and angle 5 are corresponding. Angle 5 and 8 are vertical. We could also look at angle 1 and angle 8 are alternate exteriors, even though 8 is interior, but if we look at just the lines K and M, they're exterior to that particular set of angle or set of lines. We could then go on around and again apply all those rules. All right, so let's go ahead now and let's identify those congruent to angle 2, and we'll again stick with our pink. So angle 3 is vertical to angle 2. Angle 6 is corresponding to angle 2 and is also an alternate interior to angle 3. Angle 7 is vertical to 6, but he's also corresponding to angle 3, and he is also an alternate exterior to angle 2. And we can then go ahead and apply to N, line N here, where angle 7 and angle 10 are alternate interior. And again, of course, 11. All right, so kind of sticking with that, we do know that vertical angles are congruent. We also know that linear pairs are supplementary. But what we want to focus on is what the question is actually asking us. That statement is, which of the following statements are sufficient to conclude that two lines are parallel, then when they are intersected by a transversal? All right, so again, we're trying to prove that the two lines are parallel. So we need to think about our properties that we can prove or use to justify that specifics, and that's the converse of some of the theorems we've been using this particular cycle. All right, so let's read our first one. Corresponding angles are congruent. Well, let's think about some of our corresponding angles. Let's say we have angle 2 is going to be congruent to angle 6. We also know that angle 6 is congruent to, say, angle 10. So those are all reflective of the property of corresponding angles when we have parallel lines cut by a transversal. And if those angles are, and again this is the converse of the corresponding angles postulate, is that if corresponding angles are congruent, then we have parallel lines. So statement A is a true statement. All right, vertical angles are congruent. Well, by definition, that is true. So that would be like, for instance, angle 2 is congruent to angle 3. Does that have anything to do with proving like lines K and M are congruent? I don't think so, because if you notice, 2 and 3 are only cycling around the angles the line K and the line T. So therefore, vertical angles that are congruent, that is true by definition, does not help us prove parallel line. So that does not prove parallel lines. Okay, so B is not an option. Consecutive interior angles are supplementary. All right, well, let's take a look at some consecutive same side interiors. So for instance, angle A and angle 10. Well, these are definitely consecutive. And we know based on proofs we've done before that consecutive angles that are formed by two parallel lines and cut by a transversal are going to be supplementary. So the converse of that statement is also true, that if we have consecutive angles that are supplementary, then we must have parallel lines being cut by a transversal. So this statement is also true. Alternate exterior angles are congruent. Well, much like all of our previous ones we've discussed, if we have to think about our original statement. If parallel lines are cut by a transversal, then the alternate exterior angles are congruent. The converse of that statement would be that if we have alternate exterior angles that are congruent, then the lines cut by a transversal must be parallel. So this statement is also true. It can be used to prove the two lines are parallel. Same side exterior angles are supplementary. This one is a little bit tricky because it's not directly one we have learned. So same side exterior angles would be, for instance, let's say angle 2 and angle 8. Well, if we look at that, they are on the same side of the transversal, and they are also different colors. Angle 2 is one of our pink angles, and angle 8 is one of our green angles. And we already know based on other properties, for instance, the consecutive same side interior angles are supplementary. Well, these can also be proven through the transitive property and others that these two are also supplementary. So even though it's not one of our rules that we have listed, this statement here is also a true statement. All right, the next one, linear pairs are supplementary. Well, this is true. We know that by definition, linear pairs are supplementary. But again, the question comes back to, can it prove that two lines are parallel? And much like our vertical angles, even though that's part of the definition, that statement cannot prove that we have parallel lines. All right, so therefore, for this particular problem, A, C, D, and E are all true statements. And again, they're true because they are going to be sufficient to conclude that two lines are parallel when they are intersected by a transversal. Again, vertical angles and linear pairs are true based on their definitions, but not able to prove lines being parallel. Thank you.